Okay, database, COS 300. We continue to be in Chapter 7 of the Kroenke book. And in particular, this talk will be on views. These slides were modified from the Kroenke Chapter 7 slides, which you can download in their entirety due to the COVID-19 online teaching that we're doing. I've modified this section a bit, and I want to be sure to give Kroenke appropriate credit. So SQL views. A SQL view is a virtual table that is constructed from other tables or views. So far, we're used to tables having actual data in them. We have the sense that somewhere out there on disk is a bunch of data, and we're just organizing that with our SQL tables. And that's essentially true. That's a right view of the world. So a view is a virtual table. It doesn't actually exist on disk, but we're going to pretend it is because it's going to be useful to us. It's going to be another application of the idea that when we do a SQL statement, we expect a set as our input data, and we produce a set as our output data. And we can pass that set around, as we've already seen. Views are another way to pass that set around, modifying it as we go. So a view has no data of its own, but obtains data from either tables or other views. I can layer as many views as I want. I have view and view from view from view from view from view. Eventually, I've got connected to a table, or there's no data. And if there's no data, it's not very interesting. So we're going to use a create view statement to create a view, and we're going to use a select clause to define where the data in the view comes from. Could be from another view, could be a table. Ultimately, it has to come from a table or there's no data. And I would note that you can use about anything you can do with the select. As you've seen, you can do all sorts of crazy things with the select. You can do all those crazy things except you can't use an order by clause, okay? If you think about it, an order by would break our definitions of a table because they would say, oh, the rows have to be in a particular order. And we've already said we don't want tables to be dependent on a particular order. That would break first order normalization, right? And we don't want to break first order normalization here with our view. So no order by in the view. You can use a view to do a bunch of other things, and then you can refer to that view from a select, and that select that refers to the view, that can have your order by clause, no problem. So we can do all sorts of things with views. We can hide columns or rows. We can display results of computations. We can hide complicated SQL syntax. If we have some complicated syntax that we use a lot, like maybe a big set of joins, we might be like, this is tedious. We could just build those into a view once and then refer to that view. We can layer built-in functions to have what looks to be a column, but it's actually calculated. We can provide a level of isolation between the table data and the user's view of the data. I'm going to talk about this a bit more in a slide or two. And we can assign different processing permissions to different views of the same table. These both have to do with controlling who sees what, which as students we don't worry much about, but actual corporations worry a whole lot about it. And the view gives us another set of very powerful tools to control that. We've mentioned triggers. We haven't talked too much about them. We'll do that real soon now. But there are some limitations on how many triggers you can assign to a table, but you can insert a view so that your view is basically the same as your table, and then you can assign different triggers to the view, even though all the view is doing is showing the table. It gives you a way to get around some of the limitations on triggers and tables. Okay, so let's look at a create view. Here's a create view command. Create view is a very simple view. We give it a name. Kroenke and Auer like to put the word view in their view names, like here, customer name view. You can call this Fred if you want. It's just a name. Although putting view in there might be helpful to you, and you might use that as a rule, but it's not required. So we create view as, right? We're used to having columns here, but instead we'll have as, and here's our select statement, and we can put anything we can put in a select statement except for the order by, And here we're selecting from what? Select has a from clause. Here we're selecting from customer table. We could say from and specify another view there. We can chain as many views as we want. What this is going to do is it's going to pick out two columns, a last name and a first name column. And you'll notice it also aliases them. We say select last name as, and we has a customer last name. So we're using the as an alias. We've seen this earlier, but what this means is that when we access through the view, it will know the name we picked here as an alias, but it won't see all the aliasing syntax. It's a way to simplify it a little bit. So we create our view, we do our select from some table, and then how do we use it? Well, here's an example down here under the word results of us using our view. We say select star from customer name view. Now, does star give us everything in the customer table? No, it gives us everything in customer name view, which was a total of 2 columns. And of course, if you look at what how it ran, it thinks that the aliases are just the column names, right? And now we want to do an order by, and here's where we drop our order by. We're not allowed to drop our order by into the view, but we can drop our order by into the select that uses the view. Okay, so basic create view. Now, when you create your view, it gets put in the database. There's a view in the database named customer name view as a result of this create statement. And it will stay there and let us use it multiple places. Okay, what about updating? Suppose I have access to a view. Maybe it's this customer name view. Can I update? You call an update using the view instead of using the table. And the answer is sometimes. And of course, in programming, we're always a little put off by this sometimes. Sometimes what? Well, there's something called an updatable view, and that's a view based on a single table with no computed columns and all the non-null columns present in the view. Let's think about this for a minute. Suppose I had a table. My view was basically dealing with a single table. And suppose that my view had a computed column, like maybe it computed your paycheck based on a salary or something. Okay, and I call an update on that. Well, the computed column doesn't actually exist in the table, so how would do the update? More or less, you can only update stuff that actually lives in a table somewhere. You can go through layers of views to get to it. You can change its name, but ultimately, if you can't get to it in the table, you can't update it. The same with this non-null column. Now, if my table had some column that could be null, I updated it through the view, or maybe I did an insert through the view, what would happen to that column? Well, if I don't provide a value, it picks up a null. Or maybe I have a default value. But if I'm trying to do something like an insert through a view, and the view doesn't have some required column, but the table does, then I can't succeed in inserting into the table. So you can update through a view, but ultimately the thing you're updating in the end eventually is a table. And if you keep that rule in mind, all of this stuff makes sense. So a possibly updatable view, if you have a view based on a single table, a view can use multiple tables, but if you do, there's a problem doing an update or an insert, okay? So based on a single table, primary key in view, some required columns are missing from the view. Update and delete may not be allowed. Insert is not allowed. Let's take the insert as an example. I want to insert through my view, but my view doesn't include a required column. How would that work? Okay. Now, multiple tables, we can base our view on multiple tables. An update might be allowed on the most subordinate table in the view if the rows of the table can be uniquely identified. So ultimately, all of these update rules are saying, you know, your view is just a path to get to a table on the disk. And if you can't get to some of the required elements of that table, you can't change it. When you think through it, it makes perfect sense. Okay. After you create a view, I mentioned that once created, the view is persistent. You call your create view, and it stays even after you log out. It's stored in the database server. somewhat like a table, except it's marked so that it knows that there's not actually data with it. And so you create this view, and then months later something happens and you need to change it. How do you do that? Well, to change an existing view, there's a statement called alter view, which is similar in functionality to an alter table. You can add a column to the view, you can delete a column from the view, you can do a number of things, you can add a key. There are a number of things you can do with an alter view. They're very similar to alter table. To remove a view from the database, we have a command called drop view, and it's similar to drop table. But since the view has no data of its own, it's much safer. If I drop a table that has a bunch of data in it, I lose the data. The data is now gone unless I have a backup somewhere, and that's not really related to the database. But if I drop a view, the definition of the table of the view is gone, but it had no data of its own. So the data is there somewhere. So if I could find my create table statement and run it again, I would be right back where I was before I dropped it. So it's much safer, as you can't lose data doing this. Now let's mention some of the reasons that views are important, because as a student you're thinking, well, I can just create tables. I don't really care. This is more work. Okay. Often for many companies, all programs are written against a view. They never allow a normal programmer to specify a table in their program. Okay, there's a position in companies called a DBA, a database administrator. Database administrators are like the super user of the database. They have the rights to get at everything and to look at everything. And then you're writing your code in some other language, like maybe PHP, and you're accessing this. Very often, they'll only let you access against a view. That allows the DBA to change the table without affecting the program code. If you do something like you say select star, okay, and then you refer, so you get back a bunch of rows, or a bunch of columns, I should say, and then you're printing things out referring to the column number. We've seen that where we use PHP and we get back a row and we say, you know, row subscript 0. Well, what if the DBA inserted a new row, a new column into the table? Well, then you're going to pick up that new column with your select star. And then what shows up in a particular row is going to depend on the addition of that new column. Or maybe you delete a column so that column's no longer there, something like that. But if we write it against the view, then the DBA can change the tables and it doesn't affect the program code until we change the view, right? And we're more careful with the view. We may very well, if we add a column, we may create a new view that includes the new column and leave the old view alone. That way we're sure we won't break code that already works. If you got a company like Bank of America, they hate breaking code that's already working in front of customers. It's bad, has a lot of bad consequences. Okay, often there are views that don't include sensitive information such as salary. So perhaps we've got some kind of an employee table at Bank of America or someplace, and there's some information on that that's pretty public, like maybe your name and your phone number, right? Maybe your email address. Use it to print a directory, not a big deal. But then maybe somewhere in that customer table, there's something like how much you get paid. Now you could have a whole philosophical argument about this. I'll just say that a lot of people are very sensitive about people knowing how much they get paid. A lot of companies are very sensitive about that. You look and you say, well, this person, they're doing the same job I am and they're getting paid more than I am. I'm going to go ask for a raise. You have a whole discussion about this. But the reality is some people are sensitive about it. Okay, so we could access that employee table directly, and then if we're not careful in our code, we might display on some kind of report or maybe let a hacker get into that sensitive data and see it. But if we have a view and our view only includes your name and your phone number and your email, and I write a program against that view, then there's no way I can accidentally show someone's salary. Another example is showing customers price but not cost data. You go to a place like Amazon and they show you how much the price is for something. They don't show you what it costs them to buy it, right? They don't really want you to see their markup. That's kind of very confidential information. So somewhere at Amazon, there's some database where they've got both the cost and the price of something so they can calculate, are we making a profit on this or making the kind of profit we want to make on this? But then the guy writing the code to drive the website, right? It's going to show you the list of products. You say, oh, I want to see all the blenders or cups or whatever, coffee mugs or something. I want to see all the coffee mugs. That website code is going to read through a view, and that view is not going to access stuff they don't want customers to see. So that view will have something like an item number and a product description, maybe a nice little photo of the coffee mug. It'll have the price of the coffee mug, but that view won't have the cost, what Amazon paid for the coffee mug. That way there's no way for the person doing that website to screw up and show you the cost data. Now, to top this off, we haven't gotten into multi-user stuff yet, and we don't spend a lot of time on this in this course. It's more an administrator thing. It's more of a DBA thing than a coding thing. But the DBA, not only can they create the view that's limited, so you only see certain things, but they can also put permissions on those. So for instance, the website runs under some user ID, right? That user ID, if there's code in there that accesses the a view or a table, but in our case for today's talk, a view, that has permissions. That table or that view has permissions on it that the DBA set. And so if we write code that tries to access the table or even that tries to access a view, but a view that may have sensitive information in it, and it's for the public, it's the ID for the public website, the DBA can set permissions so that that program will fail and blow up instead of the end user out there in their browser seeing stuff we don't want them to see. Okay, so views give the DBA an important set of tools to control who sees what. DBAs spend a lot of their time being concerned about who's allowed to see what, who's allowed to change what. You know, we don't want an employee to go in and change their own salary, for example. Maybe changing a salary, it's only done if you're in the HR department, something like that, or if you're a manager. Whatever the company comes up with, the company has rules about who gets to change what, who gets to see what, and the DBA implements those through permissions. But to allow them to apply the permissions well, they make use of views. They say this view has these people can use this view, and this view only looks at things that these people are allowed to see. Finally, one other thing, a view can be used to unnormalize data for particular operations. Let's say, let's think about our ViewRidge thing we looked at a little while ago. We had customers and we had artists and many relationships. So we had 3 tables. It may be that we would have some applications where we would like to pretend that, oh, we have a table where the customer and the artist they care about are in the same table. But we know it's not good to do that permanently because we know it's important to normalize data. We can have a view that pulls things in from all 3 of those tables and puts them out and creates this temporary, this virtual table that's not necessarily normalized, but it's very easy to run the queries against that we want. So these are some of the common uses of views. Often they don't strike students as being very important. They strike students as being one more thing to keep track of. But they provide powerful tools on controlling who can see what in our database.